What's up, y'all? Welcome back. Today, I'm going to make a video going over the review that is posted on your Math Excel. Okay. Now, these problems are not going to be exactly the same problems that you will see on your Math Excel. Some might be the same, but most of them are going to be slightly different. But it's going to be the exact same order, the exact same kinds of questions. Okay. So this will give you something to look at when you are reviewing for our last test. All right, which is going to be the week of the 7th through the 11th. All right. So the very first problem you will see, it's going to give you a polynomial, okay, and then it wants you to write it in standard form, find the degree and the leading coefficient, all right? If you remember back when we did the very first section of this topic, topic 3, standard form is when you put the exponents from the biggest one to the smallest one. So I just want to reorganize this. So 5w to the 4th is the biggest exponent, w to the 4th. Then I like to cross them off as I go. The next one is 2w squared. Then 4w, it's a positive 4w. And then plus 18. That is standard form. It goes from the biggest exponent down to the smallest exponent, okay? Remember the degree of a polynomial is always the biggest exponent. So in this case, the degree would be 4, okay? So the biggest exponent is a 4, so the degree is 4, all right? And the leading coefficient is the number in front of the degree. So coefficient means the number in front, and leading means first. So the number in front of the biggest exponent, in this case, is a 5. Okay, so the degree is 4 because it's the biggest exponent. The leading coefficient is 5 because that's what comes first in front of the biggest exponent. All right? There's going to be some questions like this on your exam, okay? If you have questions at any point, just reach out to me and let me know, all right? The second question wants you to add these together, right? It just wants you to combine like terms. So all we need to do is pick out things that are the same. So we just look, 9x squared doesn't have any other like terms, right? So I'm going to keep 9x squared the same. And again, I like to cross them off as I go, so I know I've already used that one, all right? Then we look at, we have 7x here plus a negative 7x. So 7x minus 7x gives us 0. 7 minus 7 is 0. All right. And then the last one, we have negative 11 plus negative 11. So negative 11 plus negative 11 is negative 22. And we're done. Right? We are just combining like terms there. Okay? And we're just adding them because of that plus sign in the middle. All right? The third one is really, really similar, but the third one is a minus in between them. Okay? So we're going to do the same thing we just did. All right, but it's going to be subtract. Now, what I like to do whenever I subtract is I like to change it. I don't like to subtract, so I like to change that to multiply, and that changes everything after it. So that becomes a positive 3y, and this becomes a minus 6 right there. Okay, so I like to change them all just to make it easier. And now it's exactly like what we did on the problem right above it, right? So 3y squared, no other y squareds, so that's going to stay the same. And I cross it off. Then I have 8y plus positive 3. So now I don't have to worry about the negatives as much, right? A little bit, but not as much. So 8 plus 3 is 11y. And then the last one, we have negative 3 plus negative 6. So they're both negative. So that means we actually add them together. So that gives us negative 9. There's my final answer. Okay, so you just combine like terms. Remember, the variable won't change and the exponents won't change. All right? Number 4 is a problem that looks like this. So these problems had a plus and a minus in between them. Notice number 4 doesn't have anything between the parentheses. That means we have to multiply. Okay? So we're going to distribute. So we're going to distribute x times all of them first. So x times x squared is x to the 3rd. X times 3x is negative 3x squared. Then x times 2 is 2x. So I distributed the x to everything. And now I'm going to do the exact same thing, but do it with the negative 6 now. So now distribute that negative 6 to everything. So negative 6 times x squared, negative 6x squared. Negative 6 times negative 3 is positive 18x. and negative 6 times positive 2 is minus 12. So we distributed, and now we've got this big long problem, and now we just combine all the like terms and get rid of things, basically, right? We're going to make it a little easier on ourselves. So you'll notice there's an x cubed right here, and there's no other x cubed. So that one's going to stay the same. And again, I like to cross them off so I know that I've used it, okay? So x cubed is done. Now we have a negative 3x squared and a minus 6x squared. So negative 3 minus 6 would give us negative 9x squared. Cross that one off and that one off. All right. Then we have a 2x plus 18x. 2 plus 18 gives us 20x. Cross that one off, cross that one off. And then I'm just left with the minus 12 on the end, right? There's no other like terms there. Boop, boop, boop. All right, so we just distributed and then combined the like terms to get our answer for number 4. And again, these are just like your review that you'll see on Math Excel, along with on your exam, okay? So number 5, let me pull number 5 up. Here's number 5. So 3x minus 4 times 3x plus 4, okay? And again, there's nothing in between them, right? So that means we are going to multiply. So we're just going to distribute again. 3x times both, so 3x times 3x, 9x squared. 3x times 4, 12x. And then we do the same thing with the negative 4. So negative 4 times 3x and negative 4 times 4. So negative 4 times 3x is minus 12x. Negative 4 times positive 4 is minus 16. And then we look here in the middle. I have two like terms, right? But 12 minus 12, they go away. So those two are going to cancel each other out. So I am just left with 9x squared minus 16 as my final answer. All right? So again, we are just distributing. Distribute, distribute, distribute. Okay? All right, number 6 wants us to factor this. Okay? This is what we talked about in section 3.3, where they're both cubes. So 64 is a perfect cube, and n cubed is obviously a cube, right? Because it has a 3. Okay? And if you remember, we talked about a formula. Whenever it was a cubed minus b cubed, right, that turned into this. And we talked about same, opposite, always positive. So it would turn into a minus b, a squared plus a times b plus b squared. Okay, so this is how we're going to factor this thing. All right. And if you look, 64 and a cubed are in the same spot, right? There's a minus in the middle, so a cubed comes first. So 64 equals a cubed, and that means n cubed is where the b cubed is. So n cubed equals b cubed. And then to plug, we need to know what a and b are, right? Not a cubed and b cubed. So I need to get rid of that cube, right? I need to get rid of that exponent of 3. So to do that, I'm going to do what's called the cube root of both sides. And this is where your calculator will come in handy. The cube root and the cube cancel, so I'm left with just a. And the cube root of 64 is 4. That's 4 times 4 times 4 is 64. Okay, and you can just put that in your calculator to get that answer. We're going to do the exact same thing over here, right? Because I need to get rid of that 3 with the b. So I'm going to do the cube root of b cubed and the cube root of n cubed. So again, all of this is going to cancel. Leaves me with n equals b, which I know is really, really weird. Okay, n equals b doesn't really make a whole lot of sense. Now I'm just going to take this 4, put it in wherever I see an a, and I'm going to take this n and put it in everywhere I see a b. All right, so if I did that, a is 4 minus b, which is n. So we just substitute. My next parenthesis is a squared, but a is 4. So I'm going to do 4 squared plus a times b. A times b would be 4n. A is 4, b is n. If I multiply them, I get 4n plus b squared, and b is n. And then I'm just going to do 4 squared to kind of finish this off. So 4 minus n times 16 plus 4n plus n squared. There's my final answer. 4 squared became 16. Okay? All right. The last problem, number 7. Well, there's actually two problems, number 7 and number 8, but they're both the same thing. All right? This is long division. This was section 3.4. Okay, so 3.4. So what we're going to do, remember, we always look at what comes first. Okay, so I have k to the third and I have k. Don't worry about the 5 and don't worry about any of this to start. Also, remember, it has to go in order. So 3, exponent of 3, exponent of 2, exponent of 1, 0. So that means it went in order. If something was missing, we would add a 0 in. All right, so what I need to figure out is what times k would get me k to the third. Okay, something times k that would get me k to the third. So basically I'm asking you, k times what equals k to the third, right? We need to figure out what that term is, all right? In this case, that would be k squared, because k times k squared gives me k to the third. So I'm going to put k squared on top. And remember, we line everything up, all right? And then I multiply. So k squared times k is k to the third. K squared times 5 is 5k squared. And then remember, we always subtract. Will always be a subtraction problem. If you've done this right, the first term should cancel. K to the third minus k to the third, they cancel. 1 minus 1. 8k squared minus 5k squared is 3. 8 minus 5 is 3. And then remember, we pull down the next number. So plus 24k. And we repeat the exact same process again. All right? So we do the exact same thing. But now I ignore the 24 and just look at the 3k squared and the k. So now I'm asking you, k times what would give us 3k squared? Okay? So I have 1k right here. So I know I need one more. And I also need the 3. I also need 3, because 3k times k is 3k squared. So that's what I would put on top now. I would put that 3k. And then again, I multiply. 3k times k is 3k squared. 3k times 5 is 15k. And we always, always, always subtract. All right? 3k squared minus 3k squared, they cancel. 24k minus 15k is 9k. And then we have one more number to bring down. I have the plus 45. Plus 45. So now, what times k would get us 9k? So k times what equals 9k is what I'm asking. Right? That's how we're going to figure out what number goes up here, whatever this would be. In this case, it's just a 9. K times 9 is 9k. So I'm going to put a plus 9 on top. 9 times k is 9k. 9 times 5 is 45. And I subtract 9k minus 9k, nothing. 45 minus 45 leaves me a remainder of 0, which is great. Right? I did not have a remainder, so this is my final answer. All right? Remember, if there would have been a remainder, okay, so that's our answer to this problem, but if there was a remainder, so let's say this was a 2. Let's say I had a remainder of 2, right? That would mean that my answer, I'm going to rewrite what I have up there. If I had a remainder of 2, remember, whatever's left over, if that was a 2, so let's write it up here. If there is a remainder, remember, we don't write R anymore. So if there is a remainder, write as a fraction. Okay, so if there's a remainder, write it as a fraction. So if this same problem, if it had a remainder of 2, my answer would be that same thing plus 2 over whatever the remainder is, whatever I divided by, k plus 5. Okay, so if there was a remainder, just write it as a fraction. You do all the same steps, you just add that fraction on the end. Okay, This problem, the answer is right there with no fraction because there's no remaining. Okay? So hopefully that will help you out if you get stuck. This is a great video for you to use to review. And next week will be your exam. Okay, you all? Thank you very much. Let me know if you have questions.